Welcome everyone to the Flux Dev Meeting for July 6th.
Hey everyone. So for today we could discuss the changes we are doing in hand controller and customized controller around reactivity to config map and secret changes. Then Lee, I'm guessing you want to discuss a thing that's related and not quite. Then Adrian, you want to introduce yourself?
Yeah. Hello. Hello.
Hi.
Um, yeah, I was just doing the call just to keep up to date with the latest updates with Flux. Right? So I've seen that have been uh yeah uh, a number of releases these days. So I wanted to see what was there. And well, on top of that, I have, let's say, an RFT there that is it's, holding a little bit. So yeah, just to see if you would like to resume the conversation or um, discuss about it.
Is the open telemetry one?
Yeah, yeah, that's the one.
Okay. Okay, we can make some time and discuss open telemetry as well. Cool. Okay, so let's discuss a little bit about the config map and secrets watchers. So we discovered there is a new, I don't know how new it is, maybe half a year old or something like that. So there is a new type of watcher in control runtime which allows you to subscribe to change events of a type, but only receive the metadata in the event payload. And we've seen that many controllers which deal with secrets and config maps have switched to this new type of watcher, which means if you have, I don't know, lots of secrets because you use Helm and Helm stores in the secret all the YAML of everything that deploys. So you have like these huge secrets. What the result is, if you just watch secrets normally with a controller runtime watcher, your controller will run out of memory very fast, or it will use huge amounts of memory. Now with the metadata watcher, the you never receive the actual content of the object. So you don't receive whatever is in the secret or whatever is in the config map. What you receive is the name, the kind, the namespace, and then based on that information, you can decide what you want to do next, which fits perfectly for our use case. We
You
want to
probably also
watch,
receive annotations and labels as well, but like
yeah, metadata, yeah,
metadata.
yeah,
Yeah. But
yeah,
it's
and
probably
this,
small, hopefully.
yeah, this fits very well with what we want to do, where we want to trigger a Helm release upgrade when values from changes. We want to trigger a Helm release upgrade when a kubeconfig secret changes. We want to trigger a customize apply when variables changes, kubeconfig changes, or the secret reference in the decryption the decryption ref changes, like I don't know when you rotate your SOAPs keys or stuff like that. So Mateus has implemented this in Helm controller. We still need to do load testing for it. You already did, Mateus, some load testing, 1,000 config maps, 1 megabyte each. restricting Helm controller to 200 megabytes of memory, nothing actually changes, just a little bit of CPU time for receiving and processing the small metadata. So this scales really, really well. The next stage of approving this feature will be to have a cluster with 1,000 Helm releases, 1,000 config maps, 1,000 secrets. Then, and of course, each Helm release will have a reference to a secret and a config map. Then we are going to update all 2,000 objects in etcd, change some values in both of them, and see how long it takes Helm controller to reconcile the 1,000 Helm releases, how is the queue doing, and so on. So we have currently a benchmark where we do exactly this, where we create 1,000 Helm releases, then we upgrade them all by doing a change in the inline values, in the Helm release values. So we have the numbers, we know exactly how long it takes, and what is the CPU and memory profile. So we can compare the two and see the differences.
I have this load test running right now, and I have a couple of questions. The first one is, does the config maps and secrets, the 1,000 each, need to be large as well?
No, 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 no. So
Okay.
this can be as light as possible. Like we assume that people will enable watchers for a particular label that we have set as default, right? So we should optimize for this when you don't just watch every config map and every secret in the cluster, you only watch, or you watch them all, but not the Helm storage ones, right? So we assume Helm controller watches the thing that contains values, which are tiny. You'll not have a 1 megabyte YAML of values file for a Helm release. That's insane. No one has such a thing, right?
Okay.
So
And the second question is, would it work if I did 1,000 Helm releases, all referencing the same config map? So I can change only that config map, and this single event
no,
will trigger all of them?
no. So the idea
No?
is, no, the idea is what happens when you have 2,000 events that
So
needs
we
to be
really want to know
processed.
the impact of receiving events.
Yes. And
Matthias,
triggering upgrades, right?
I think that it would be good to have either blended into that load test or a separate test that ensures that the controller queues properly when multiple changes to multiple config maps that a controller that a Helm release uses are fired off in quick succession.
So
if I
this
have
is what we test, right? A Helm release references a config map and a secret. We change both of them. So for
Yes.
every single Helm release, you get 2 events of please reconcile.
Yeah, we should test that it does not behave badly even when there's like 20 informing the same Helm release. Um, w- I I tried to look to see what the controller runtime work queue would do if you queue the same object over and over again, and it wasn't clear to me what's supposed to happen.
Nothing.
Like what do you mean nothing, Stefan? Can I?
If the object is already in the queue,
Yes.
it will stay there.
Is it keyed when you add to the queue? Or does it get deduplicated already by the work queue?
So the work queue does deduplication. Last time I checked, I don't know, years ago when we rewrote Flux version 2, it does deduplication. Right? That's
I see.
the
Cool.
whole thing of
Because
that.
it's very likely as well that we might want some sort of debounce on there. I mean, if not, that's fine too. It's like,
It has a debounce. Like the default queue mechanism is well thought
Yeah,
in
I know
control
that it has
runtime.
back off.
Yeah.
But yeah, it's like if I queue the same group version kind name namespace, 100 times in quick succession, I
I
wonder how
was
much
thinking about the same.
reconcile func will run.
What does controller runtime do in that case? I was thinking the same.
It will not. So last time I checked years ago, it will, if the object is already in queue, it will just remain there without having it thousands of times. But sure, check it again. I mean, as in the last years, the queue I think has been completely rewritten. Who knows what changed in there? But
Yeah, that sounds an important thing to have in controller runtime to me.
I mean, otherwise, the way we have Flux running with that reacts to events from all parts, right? You have notification control, you have the CLI, you have events from sources, and so on. If you would requeue and add to the queue the same thing hundreds of times, like people will have noticed. But I'm quite sure it doesn't happen. Anyway, a test will not hurt.
Yeah, we should
series.
just know how it behaves. I think that would be good to look at because one piece of info we can put into the index is, or a separate index even, is just like the number of like secrets that could affect, the Helm release that could inform some sort of heuristic debounce or something. Maybe using requeue after, with like a short time window or something would naturally debounce.
Yeah, so the word queue deduplicates identical objects. This is a major feature of the queue in control runtime from May 2024. So I don't think anything changed still since then.
Okay, so
Like this will be like
requeue after would keep the item in the work queue deduplicated until you reach the scheduled.
it will move the it's a key value pair, right?
Mhm.
So it will just update the requeue time, but
So
that's about it.
that would be a debounce at that point. Then, like, we would only queue the object after some amount of time occurs, for which. But then, in order to stop the debounce, like say if the events never stop coming in, at some point you have to decide that this thing needs to go off.
Yeah, and the only way to do that is you return a terminal error, right? When you no longer reconcile. That's the goal of the terminal error.
I'm kind of thinking of the case where it's like, what if a config map was thrashing faster than our debounce window? Right, so it's like the change keeps coming in over and over and over and over and over again, and then it never gets reconciled because you're continuing to requeue. But
Yeah, I think there is a discussion about adding priorities to the queue because there is this problem where, let's say, you have a huge amount of queue, but one object receives events very fast. You should prioritize that in the queue, but currently the priorities are not that flexible, are not dynamic. So that's another discussion in control runtime on how to make this. Also, the biggest problem with queuing right now is what happens at restart. You have, let's say, 1,000 Helm releases. Helm controller goes out of memory, or the node where it's sitting disappears and you need to restart, right? While the node is provisioned, let's say it takes a couple of minutes, customized controller it's running, it's not on the same node. It applies changes to Helm releases. They have 1,000 Helm releases in etcd at the moment that Helm controller died. Then some of those have received changes. Then Helm controller starts, and what Helm controller receives is the whole list of the Helm releases in the order of the UID in etcd,
Mhm.
which is bad because instead of prioritizing the ones
Yeah.
that have drifted, that have
Mhm.
changed, you need to process a bunch of ham releases and say, no, nothing changed, nothing changed, nothing changed, nothing
Yeah.
changed, until you reach those in that order. The discussion in control
And
runtime is to
the
introduce this
order is
priority queue.
completely abstracted from you because you're only writing a reconcile func and doing work as soon as the work queue gives it to you. So it's the
Yeah,
work
yeah.
to potentially pick an order that's less pathological.
Yeah, so the order should be when you fire off the cache, when you init the cache and say, hey, I want all these object types. The order of which you should get them in the queue should be based on last update time. And those that were recently created or updated should be the first in the queue, should have maximum priority. So when you restart a controller, the first thing that will work on are things that are there new, so it should prioritize them. So I'm not sure if it's in the latest control runtime or if it's in main and not yet released, but this change is definitely coming and it's very, very good in general as an optimization for the priorities. Right. But going back to the load test stuff, what I'm interested in this load test is more about what is the impact of dealing with thousands of events which are new to Flux, right? So for people that are running now 1,000 hand releases, the amount of events that they receive are based on, is the generation of the hand release change or not? Is the source revision change or not? These are the only two events that we currently subscribe to and deal with. Now we have, with config maps and values, we know everybody uses them everywhere, especially in hand releases. What is the impact on CPU and memory usage once people, let's say, will deploy this, will label order things, or they choose not to label anything and say subscribe to all config maps and secrets. So that's what we are trying to measure to see the actual impact, right? Before we tell people, hey, you should label all things, or you should, just set a label selector that catches everything besides hand secrets. If Matteo would say like, we should recommend people to subscribe to everything. Right? I don't think we should do that unless we have like hard evidence that this does not seriously affect Flux at scale, right? So we need to do this.
I
So
think
sorry, go ahead. You can go after.
just on that last comment and then you can say something, Matthias, sorry. Yeah, just having filters that already remove the chart cache will reduce the copy from API server into Helm release substantially. Or sorry, into Helm controller, from API server into Helm controller memory for the informer, just removing the charts from the rendered releases from the secrets is going to be a huge reduction in volume. But there are lots of other reasons why people might be writing large amounts of data into config maps and secrets, and you don't really have control of that. So I think like the best default is for Flux to recommend that people label specifically, and we can provide a note, for platform admins who cannot control their values from labels, that they can configure for something more wide.
Yeah, we actually have this in the docs right now.
Yeah.
But
then,
we say, hey, you can actually do this selector to if you don't want to label. But
yeah,
before we merge that, I really want to see a load test. So we
yeah,
are not telling people to
nice.
you know, impact Flux in various ways, then we have to deal with the aftermath.
And just
That will be very bad.
right, Mateus, I really want to get to what you're about to say. The only other thing I have to add to this is on the API server side, since Kubernetes 131, we have reads from consistent cache for label and other predicate type filters. So the API
Yeah.
server will not do another
etcd lookups, yeah.
from etcd after Kubernetes 131 and with further bug fixes in 133. So most API servers will every API server is basically going to already have all of the config maps and secrets continually up to date in memory already. So this additional shared informer should only be another request loop in API server, just filtering that existing cache, but with no further reads from etcd.
Yeah. Sadly, big users of Flux are on Kubernetes 120 something, and it'll take them 5 years to go to 133. So
Yes, yeah.
it
But
is
even
what it
in those
is.
cases, then on API server side, right? Like we're talking about reads from etcd using protobuf deserialization, on core APIs, config map and secret. But yeah. Okay. What did you want to say, Mateus?
I'm just thinking how I'm gonna, because if the point is measuring the impact of processing a lot of events, I'm not sure, at least the way I'm doing right now, will cut it. So I was wondering if the benchmarks that we already have something like parallelizing the changes to the config maps or something, because like I'm doing like in serial, like one by one, and I don't think patching one config map at a time or something will be fast enough with the latency I have with Amazon to simulate this very well. So besides we think about a solution for that, or if that's even a problem at all, why I thought it was a good idea to make all Helm releases point to one config map, which is a giant one, is because I think with this, I'm gonna generate a fuck ton of flows in Helm controller very fast. Like I am on 850 Helm releases now, so just 150 to go. And when I change something in the config map, I'll see the storm in Helm controller by changing just one config map. And in this case, we'll not be testing the impact of processing events in the queue, but we'll see the impact of 1,000 Helm releases reconciling at the same time with a config map that weighs 1 megabyte. So I guess
Yeah,
it's
but
a lot of load.
Yeah, but it's not relevant at all for how Flux is running. So no one has a 1 megabyte values file. No one has 1,000 releases referencing the same values. So that's
Sure. But if Helm controller goes fine with this, anything will be fine.
The config map read from that time window will probably hit the cache. So I would expect
There's no cache. We don't cache.
we don't cache anything. We don't cache secrets and config maps.
Oh, we're not using the controller runtime client for that.
So it will be a storm.
Yeah. We
So
can't
that's why
cache
I'm
anything.
saying, like, if Helm controller can stand this, which is, I agree, unrealistic test. But if it can stand this, it can stand anything.
Well, what's your concurrency setting for the controller deployment?
The
When
default.
4 then?
Yeah.
Eh.
I mean, it will do fine if you have enough CPU. So what you are testing here is the Go garbage collector, nothing else, with the 1 megabyte config map. I already did all these tests in the benchmark. So it's everything is tied to when you deal with large objects in a reconciliation loop, everything is tied to how modern is the CPU underneath. And depending on how modern it is, the Go garbage collector will be really fast and really on point, or it will be lazy and you'll run out of memory. Like, for example, if you go with the default Ubuntu runner in GitHub Actions, which uses very old AMD processors, the garbage collector will be very, very lazy, while the machine that I'm using now, which are the new Intel Xeon, it's crazy good. Like the memory goes almost, it's released almost immediately after the reconciliation exits.
What the
Keaton shared in
latency of
the
downloading the config map cause like IO to slow down the reconciliations a lot?
1 minute. But I mean, it also depends on what machine are you testing this. What type of runner, what type of node are you using in
It's
EKS?
the same one we have in the I just EKS applied that cluster we have.
Oh, okay. So it's not the CPU optimized one. Okay. Yeah.
We are about to know it's 930. Before the call ends, we'll know.
Kingdon just mentioned that his
Yeah, I have done some experiments to make my values as large as I can. Not with that explicit purpose, but as large as I reasonably can for a valuable reason. I'm monitoring a bunch of different cross-plane configs with cube state metrics. So I have a generated values.yaml file that has a huge list of RBAC rules and
Mm.
resource kinds, and it's only 36 kilobytes. But I only have like maybe 100 resource kinds in here, probably less. So it could grow to a megabyte at some point, but it would be a lot. I think
It can't grow to 1 megabyte
first.
because you'll not,
Something else would fall
Helm
over.
will fall over. Like, do you know that Helm stores the values and all the generated resources in a secret, and the secret is limited to 1 mega? You'll never reach a values of 1 mega. Helm will fail way before.
Yeah, I would probably have to split this into config maps and just handle them separately. Outside.
Different Helm charts.
Yeah.
can Helm storage not serialize over multiple secrets, Stefan? I never tried.
No.
So it just runs out.
Yeah,
Oh,
you need a
that's
Postgres database to go over that limit.
okay. Makes sense. Cool. Well, you could have a really big Helm release if you're storing stuff in Postgres JSON, right? Or
Yeah,
actually,
we don't support that. It was
yeah,
a
we
single
don't.
request for Adobe from Adobe long time ago, but we never got to implement Postgres and MySQL backends for Helm controller.
I was actually thinking about this while I was trying to sleep last night about how that would be another great way to remove Helm storage from a cluster is to put uh, a database for Helm storage co-located with Helm controller or something. So then it wouldn't be Kubernetes API anymore. But you might as well just shard. Well, there's size limits in SCD, you know.
Yeah, I mean, Helm has this for a very long time. There are storage drivers
Mm.
and people that have these kind of issues where they store in their Helm charts, they bundle binaries. I don't know what they do there. Serialized binaries or something in, or whatever is happening there. They use a storage driver, which is not a secret or a config map, is an actual database. And you
Yeah,
have
or just like
to
really massive umbrella chart or something.
So the actual Helm secret is almost 500 kilobytes from my 50 kilobyte values file.
So
Um,
the the optimization that Helm v3 did was the content of the secret is a tar. Right? So
Double
you
base
could get
64 encoded gzip tar, right? Or
yeah.
yeah.
Yeah, yeah. To fit as much data as possible in the secret values. Cool. Okay, I think we talked enough about label selectors and Helm.
Kingdon, if you just like modify the chart to be twice as big or something, I'd be really curious if you hit those size limits. I guess we probably have a test for that somewhere in Flux, maybe.
No, it's in Helm. I think
Yeah,
Helm
but I
has a
just
test.
wonder if we have a sad path test that expects that to fail.
What exactly happens and
Yeah,
Oh no, the storage driver will return an error, and we
and then it'll
return
just
a terminal error, and that's it.
yeah.
It's
Um,
handled.
yeah. Okay. On this topic, because this is really about building an index, and then hooking it up to a shared informer, so that that index would notify, related customizations or Helm releases. Um, I was thinking that we could have a similar index for uh, depends on for customizations and Helm releases. And it turns out Mateus was like, hey, there's somebody else who already thought of that and was trying to merge that for last release window, and we just never got around to getting it fully ready to merge. Um, how similar does the index code look compared to what that contributor was
It's
building?
the index itself is pretty simple. I think Stefan had other concerns, right? Uh, we would need a flag. We're afraid of breaking some default functionality. Stefan can probably talk better about this.
For the depends on index in particular,
Yeah,
not the config map index.
Yeah,
just
yeah. So with the depends on there are. So that rescheduling basically will while customization is being processed, it will schedule it again. So we end up with doubling everything while there is a. So we double schedule everything while one is processing. We are rescheduling the same one in the queue, and people saying, "Oh, but that's not a problem because it will be no op the second reconciliation and it's not a big issue." But it's a huge issue if you have secrets decryption that makes API calls outside the cluster, so you double everything just because you want to react very fast. So that's the problem with the pull request currently implemented. It also
so how does
yeah
this
we
duplication happen? Like how do
In
we
the
end up?
so if a customization is in process and it takes a very long time, right? You deploy something, then it does health checking. It can take minutes. That depends on watcher will add the same customization again to the queue,
Okay, so
right?
if it's taking a long time.
And it always takes a long time, always, because everybody uses wait in customization. People are deploying things that don't take milliseconds. right? It's not about applying config maps and secrets. It's about applying a hand release that you wait for it. It's about applying a stateful set. It's about applying a deployment. Anything that involves a container being downloaded and spin up on the cluster will take time, right? So duplicating, requeuing is a major concern that I have with that pull request, and that's why I didn't merge it. And there is no mechanism in control runtime to defend against this.
So it's pretty much the same data structure and desire as the config map watch.
Yeah.
So I would think that we would run into pretty much the exact same concerns. Requeuing,
Yeah.
customizations, and Helm releases.
If there is a debouncer in the queue and the customization takes a long time, let's say while downloading images and health checks and things like that. Yeah, the SOPs thing would be a problem by doing API calls. But it doesn't sound like a big problem if the customization is taking a long time. It's not gonna be in queue the third time, right? It's gonna happen twice. It's gonna maybe take a long time to reconcile in both times.
What
Yeah,
if it
I
fails?
don't know.
And it goes to the timeout to fail. Let's say a stateful set will never reach its deadline. What will happen? We are going to starve the queue completely with the same stuff instead of doing new things that they could work. So no,
Yeah,
I
good
find it
point.
unacceptable to requeue things just because we want this reactivity. Like people are doing fine with depends on requeuing flag for, I don't know, since Flux 2 was there. Introducing this and risking requeuing, knowing what so many Flux users are having in these customizations. There are customizations that apply 1,000 hand releases. There are customizations which apply tens of thousands of manifests on the cluster. Requeuing those for nothing and doing dry run for thousands of things for nothing, I find it unacceptable. So no, unless we find a way to do it correctly, I'm not for going with and risking this kind of requeue, which would have major impact on massive deployments of Flux. That's why I also want it behind the feature flag. We can't do this by
I
default. It's
really
very dangerous.
agree that this can be behind a flag, because the current requeue behavior for dependencies is polling based and also behind a flag. And is your concern that we requeue both off of the polling and off of the...
Yep.
Okay. Yeah, because like we could, it might already be in there to just configure the polling to be disabled. Like we could just like provide a negative value for the requeue after. And then now you have a way to turn one off and then use the other. But I would be inclined to think that we should have the edge trigger and the level trigger.
There is also another thing in customized controller that we need to take into account. When we requeue things, we don't just requeue them. We rebuild a dependency graph and we put things on the queue in the dependency order. Right? That's another operation, another sort, another thing, right? So every time we do this kind of, oh, dependency is not ready, go, right? And you have, let's say, a tree of dependencies. You always need to recalculate everything and not trigger something that will, for sure it can't reconcile because you haven't triggered its parent. is dependent, right? And this is something, for example, that completely misses in Helm controller. In Helm controller, we don't queue based on the dependency graph. We never calculated it. I think Mateus, you opened an issue about this thing, right? And
Yes.
why we didn't bother doing that there was because before Helm version 2 GA, every Helm release will have its own Helm chart. So no two Helm releases will share a source to calculate the dependencies and do it correctly. But now with chartref, you can have a generic Helm chart, 1,000 Helm releases using the same source. So we should apply the same algorithm that we have in customized control right now. What customized controller does, it looks at which customizations share a source. What is their dependency tree? If the source changes, I'm going to put on the queue the customizations in the right order, right? To be efficient. Because otherwise, if you do it randomly, all you will do is like, you'll reconcile, oh, my dependency is not ready, right? Requeue. And instead of doing this hundreds of times, it's better to calculate it once and do it in the right order. And this is for the fact that multiple customizations can share the same source. So you know exactly that they all should reconcile, which wasn't a thing with Helm controller, but now it is, because Helm controller has a chart ref. So you can apply the same indexing and the same graph calculation that we do in customized controller. This is another big thing that we need to do in Helm controller this year.
I can take care of that.
That's mainly off of source ref only, but not for depends on, right? For the topological sort, Stefan?
So when the source ref changes, we have an index and we know what are the customizations that have that source ref. Then we order them based on the dependency graph.
I see.
Then we trigger and we put in the queue the right
And we should do
customization, the
that
one
for the
that everybody
Penzon
depends.
We should do that for the Penzon as well, because we can have the same thing. Like you can have a customization that 10 customizations depend on, and these 10 customizations can depend on each other. So we should sort in that case as well.
Oh, of course. That's what I'm saying. Another issue is the pull request. Like, if we should really take care of and not mess up. Like, YOLO queuing is not an option.
Because
right, we need to do queuing in the right order all
it's
the
like
time.
if you're reacting off of a dependency that is updated, it's very likely that an event already came in from a source that's already topologically sorted the queue. So it's like, why are you gonna be messing with the queue? Like the thing is already in there, you know? So yeah. And then really like all of this needs to be empirically benchmarked, because like the behavior is very stochastic. So that's okay.
But I think we
concerned about
can get this done, right? Like the dependency, like we can ship that, because essentially we're doing like just like a heavy customization can take a long time to reconcile and be triggered again because of a dependency. The same can happen for a config map, right?
Which is fine, because you've
needs to
changed.
be-
It's
Yeah.
very different. These are not the same things. When you change our predicate that you wrote in there filters the events by the revision. So there is a change in a config map. We should actually schedule. It's not like something happened, schedule it. We know for sure we need to schedule because we need to run a Helm upgrade because the values have changed. Even if there is a Helm upgrade running right now, if you change the values, again, of course you should reschedule and do another upgrade after the one that's running works or not, right? But in the case of the depends on, right, doubling the requeuing for nothing, because nothing actually changed, the actual customization
Yeah, okay, that's
output
fair.
will be the same. It's useless.
Yeah. In the
And it
case of
fills
a
the
Helm
queue.
release value, like you could still change the config map and the values consumed by that chart don't change, but that's unlikely, right? Like there's a high chance that you want to reconcile a Helm release after a change in a config map. And
It's
in the
so-so.
dependency, the chance is
Sometimes
not so high, right?
sometimes
It's
people are loading from a cluster config map, and maybe they change a domain and it affects half of the Helm releases in the cluster, but not the other half. So I wouldn't say it's
Yeah.
unlikely.
But I agree that in this case, the chance of needing a reconciliation is much higher than independence. I agree with that.
Yeah, and like when that config map change comes in, like the Helm release could simultaneously already be queued for a dependency graph update. So like those things need to be able to live like in the same world. Or
Also, there is a wait a second. There is a big difference between how Helm controller and customized controller works. In Helm controller, if you change something in a config map and it doesn't actually change the actual values of the Helm list, Helm controller will just skip it, because the first thing that the Helm controller reconciler does is it builds the values, compares the values with the release values. If nothing changes, skip. While customized controller will never do that. It does builds everything. It goes to the API, does drift detection, drift correction, maybe something changed in the cluster and so on, right? What Helm doesn't do. So
that's really topical to what I want to do some screen sharing on in the code on, but also recognizing that this call is normally scheduled for a little bit beyond the time window we're already at. I think maybe we should talk about the hotel RFC before I screen share.
Sure.
That way Adrian can have a stage for what he wants to talk about. Maybe. Hopefully we haven't lost Adrian to another meeting already.
Well, I'm here, but you can, I mean, we can tackle if you like it. I mean, my point was just we were in this RFC revision, so I just wanted to see if you have any comments or something. So that I guess no, at least you haven't had time to go through it. So yeah, just a kind reminder, if you can have a look and yeah, let's get something back there.
Is this the hotel integration for notification controller 1097? Yeah.
Yes,
5321. 5321.
5321. Yes, sorry. Yes, that's the one. Yeah, which seems a little
Did
bit.
you manage to change the spec like we talked last time, where we don't need to persist the ID, we don't need a database or anything like that? We can inherit the ID from the unique ID of the alert?
Yeah. Well, let's say I started very an initial phase of the development of my local. I did all the changes. So I made all the changes in the RFC description, most likely. So I just wanted to see if there was something that I was missing prior to start the actual, well, the real development. Yeah. And also, I haven't had time. I was on vacation last week, and yeah.
Okay, so yeah, I see alert object UID, source revision ID, right? So you combine these two in a checksum, and this is the span ID, right?
Yes, that's the way to spell.
And no matter the order, if let's say there is network delay between source controller and notification controller, but there is no delay between customized controller and notification controller, and customized controller hits first the notification controller, the span will be automatically created. It will no longer error out if the span I mean, in your first version, you said, oh, the span must start with the source event, which is very wrong because we can't guarantee that. Like, there is no guarantees
Yeah.
of speed, right?
Yeah, yeah.
So we always create a root span if we don't find it.
Exactly. The idea was like we check that if that checksum already exists, if don't, let's create it as a root, and then we can append the subsequent services underneath. Yeah.
Well, and what I was not, I mean, what's not obvious from the RFC, I don't know if we actually talked about it, but how do you, so let's say is this use case, right? You have Git repo Flux customization,
Mhm.
and the customization event hits first, which says successfully reconciled, revision, SHA, whatever.
Mhm.
You'll create a root span and you'll add this event to the span, right? Then 10 milliseconds after this, finally source controller event reaches to notification controller where we say successfully pulled this git SHA. How are
Mhm.
you? Will this source event show up in the span before the customization event, even if the customization event was the first one to hit the hotel storage?
Well, that's a good one, but we rely on the source. So I guess that specific scenario, we mess. Yeah, that's a good point actually. We should check the things because I mean, we can guarantee that the root span is going to be unique, but not exactly what is underneath. We haven't had any. We have at least I haven't thought any check up there. Yeah.
So basically in the span,
Mm-hmm.
the first thing that should show up is the source event. If you ever
Exactly.
receive that, it may be that people not add the source to the alert, right? But let's say if the alert contains the source, the Git repo, and the 10 customizations which are reconciling from that Git repo,
Yeah.
and you receive events like 5 customized events, then 1 source control source event, then another 5 customization events. In the span, I don't know how I imagine like in the Jaeger UI, right? I
Yeah.
should see the source event first and then all the other customizations. Even if you receive them in different order, the order
Yeah.
shouldn't matter. You should. Oh, we
Yeah,
have a
because
timestamp. Wait, we have a timestamp in the event. So you could. Can you use the timestamp from the event to reorder the?
but do you think it's important the order? I mean, if it's under the proper source, you have the trace already. I mean, you can order it. That's not a problem. But is it important?
I mean, it's important to see the source first, right?
Yeah. That's for
Because
sure. At least
Well,
that's what the I guess the code is going to check first, like
if
the
they're all
source, then
part
the
of
root, and then underneath. Yeah. Sorry. Mhm.
yeah, if it's all part of the same collection of spans with the same trace ID, then whatever is gonna be first is gonna be whatever has the earliest time for the span. Assuming the controllers all have reasonably similar clocks. Then like notification controller will have seen an event come in first, and your trace ID should hopefully propagate to things that are related, and then stuff will come in and it'll be ordered, but like the submission of the span should not be like you don't have to try to make sure that the webhook is like the first thing that you see, or the
Yeah, so there is a timestamp on the event that every Flux controller issues. So you could, even if it reaches the storage in random order, you could place the source first, because always the timestamp of the source will be before any other customize or Helm control events.
Mhm.
Because they can't reconcile something if source controller hasn't already processed it. Right?
Exactly. If there is no source, we don't have anything to process.
Exactly.
Yeah.
So maybe if you take into consideration the timestamps, or I'm guessing this is not a concern of the recorder, right? It's more of a concern of when you display the span in Jaeger or whatever, if you add the timestamp as the annotation of a subspan, then it's a UI concern how you display them, right?
Yeah.
Okay.
Yeah,
Okay, so this
there
shouldn't
should be
be an
some
issue
sort
for
of
us.
trace ID that's getting propagated somehow, right? Like how does customized controller like get something similar to the trace ID from notification controller?
It's not from the notification controller. We figure out the unique trace ID. The unique trace ID is the source revision and
Oh,
the
okay,
alert
thanks.
UID.
Yeah,
So
makes sense.
everything gets bundled under the same
Whenever
root
you're on a
span or
revision,
whatever.
makes sense.
Yeah,
Cool.
we don't need any database.
Yeah, the
Uh,
ordering is just going to be a product of whatever time windows on the span when it was submitted for that source revision, and then you filter for it. That's your trace.
yeah.
You see everything, and it's whatever's first is first. So,
Yeah, it's
um,
completely stainless. Yeah.
So
well,
Adriano, on the pull request on notification controller where you are working on, it will be nice to also see print screens from Jaeger or for something,
Mhm.
and to understand how these things are rendered. I think it will
Mhm.
make it easier for us to understand, review the code from that perspective. I mean, that's how
Yeah.
you consume all these things. Like you look at all these spans, and we think it will be really nice to see in the pull request. Yes, this is how it will show up. From the Git commit up to reconciling 3 apps from the same repo, or and another one will be for Helm chart OCI repo Helm release,
Mhm.
right? Where
Yeah.
there you can have also only 2 subspans OCI repo Helm chart, but as we talked before, there are many Flux users that have
Mhm.
these generic Helm charts where
Yeah.
you have the same Helm chart referenced in many Helm releases. Then you change your generic Helm chart, you push that, then
Hmm.
source control will pull it. Then you will trigger the reconciliation of thousands of Helm releases.
that'll look
Everything
really
should end
cool.
up in a span, right? You should see the root span is the revision of the chart, 1.2.0, then
Mhm.
app 1, app
Validation.
2, app 3, app
There's like
4, everything runs in parallel.
you'll see the
Uh,
concurrency limit.
yeah,
Like it'll be
Mhm.
like 20, and then as they splay out, then they'll start to like ladder.
Mhm.
Oh, that'll be so cool. Yeah. That's wow. I'm really excited about that. I want to show that in the Project Lightning talk at KubeCon or something. If you're there, Adrian, we can point you out and have people say hi to you.
Okay.
We can
Well,
put that
first
in
of all,
the
I need to work on it, but yeah.
yeah.
code must happen before the demo, Lee.
Yeah,
I'm just saying people like if we have that span that Gantt chart from the hotel spans of a fan out of a single OCI chart to thousands of Helm releases with a concurrency queue showing up in the downstream effect. That'll be a really, really cool graph. So yeah.
Yeah. Sorry, guys, but I need to drop. Have a nice day.
Okay.
Yes,
keep in
thank you
touch.
for
you.
coming. Thank you for being patient with our very long discussion about work queues.
No problem. It was really good. Thank you. See ya.
Yeah,
Bye.
have a great one.
Bye.
I have news about the load test. Is anybody
Okay.
interested? Uh, so I did what I was doing initially. I was doing more tests. So I updated the config map, the 1 megabyte config map. It triggered all the 1000 time releases. And I looked at the clock. It was 1:43 when I did it. And then 5 minutes later, I saw one restart due to So it took 5 minutes to get the first Then exactly 5 minutes more. No, sorry, 7 minutes after that. Another Then 5 minutes more, it finished. So in 17 minutes it took to reconcile 1000 ham releases with this 1 megabyte config map. With a 256 megabytes ham controller.
Yeah, that's no one has that. Like
Yeah.
at least run it with the defaults and 1 megabyte, 1 gigabyte of memory.
Yeah, I'll right now apply the config map again with a tiny one and see how long it takes to reconcile the 1000 ones, and then I'll do what you said after that.
What was the ham release like? What
The
are
ham
you
release
deploying?
is light. I'm deploying a config map.
Oh,
So
what
the
cluster?
config map. So yeah, the config map that feeds input values has just like a single value full bar map, and then I get this and shove this into another config map that the Helm release deployed. Both are So the 207 start. Okay. I applied the tiny one and the 1000 are getting triggered again, and I'll see how long it takes. Let me record the time.
Yeah, you should be deploying pod info, not a config map.
Cool. I wonder if does the cluster we have autoscaler for nodes?
No, you don't need. You just set replica count 0. It's about Helm controller
Oh,
doing work, having multiple objects, setting up, doing
okay.
Helm checks. There is no Helm check
Okay.
for a config map. You just so yeah. This test does not test
Okay.
much.
So pod info with 0 replicas.
Yeah, I mean you should definitely check out the benchmark. I've written all this infrastructure there. Right? It generates, it does all things correctly.
Okay.
The what was I gonna say? I forgot what I was gonna say. Anyway,
We're gonna show your screen.
yeah, it wasn't related to that, but I I was just listening to you, and then I wanted to ask a question, and now I can't remember what I was curious about. I actually feel pretty good for not having slept much. I guess I didn't really. I rested a lot yesterday. But, hmm. Oh, what cluster are you on, Mentes?
EKS.
The EKS cluster? Cool. Yeah. Thanks.
Yeah, but it's a really strange cluster because it has one R node which is very powerful and one Intel node which is very, very underpowered. Really depends on where Helm controller sits, you'll see huge difference.
It's for the workers, not the control plane.
I mean, you don't control the control plane at VTS. It's who knows what they are running there. I'm guessing it's not nodes, they are lambda functions or whatever.
Yeah.
But where Helm controller runs, it can either be a very low powered Intel machine or a very high powered ARM 64 machine.
Oh, that's why there's a difference in the workers. Okay.
Yeah, I have two workers there. We basically want to
Two
test
architecture
that
reading. Yeah.
onto architectures. that Flux works fine in a mixed cluster, basically.
Okay. Let me do a little screen share here.
It's running on AMD.
Okay. So you're running on the low powered machine.
Mm, Okay. Gonna do this and this. This is Helm controller.
It's taking a while to reconcile with a small config.
So one case that I have not thought fully about, Stefan, you might have some context on this. I guess, Mateus, you've been thinking a lot about Helm controller. Is in the reconcile func here for Helm releases. Here's the defer. Here's the quick check for terminal error for chart ref. And then here's the reconcile release that gets called. Mark reconciling. Then we check the dependency tree, get the source, check if the source is ready. It's only here that we actually try to then see if there's work to do for the values. But here we're grabbing values, and then immediately after we grab values, before checking any logic about them, since this is like one input kind of to the work to be done, we also then run secure load chart from URL. And this is kind of like linearly coupled. And then after loading the chart, right, with the values, we build a REST client. Then there is this
Release target change, that one checks.
no, this here. Oh, sorry. What?
Yeah, release target change is the one that does did anything changed or not? This is how we decide to move forward.
In here, we're only considering the chart, I think. Right? Oh no, we're taking the whole Helm release in here and then looking for a couple of different fields. But
yeah, here we decide to uninstall everything, wipe the whole thing. If you change, for example, a storage namespace, then everything has to be garbage collected and so on.
Yeah.
Anyway, this is not expensive.
Yeah, this is a cheap check. That's fine.
Yeah.
Pulling the chart feels a little bit expensive to me for getting to here, right? This must reset failures. Right, it's like we have to pull the chart before we call must reset failures because it's taking into account both the chart and the values. And
yeah, of course.
This is a very simple func that is considering both the chart and the values together. I was thinking about decoupling these two from each other so that we can check values significantly earlier.
No, you can't, because there are default values inside the chart that will change the final value. So without the charts, you can't decide if this is a no-op or not.
Because the optimization I'm thinking about is looking for basically whether or not there is a hash change only from values from. So if I look for where max retries is actually returned, in the Helm, this is checking for max retries and then returning the terminal error here. and this is where we prevent the reconcile func from ever occurring again for this unless we get a new observed generation, which is what prevents us from reconsidering whether or not the value is hashed to something else. I was thinking here we should check, right? Like, do I have values from? If so, requeue, right? Right, and if not, then like it's fine to stay in this terminal error state because no inputs are going to change. But like this case here could cause inputs to change. And if we end up then rerunning the reconcile func or say restarting the controller, even in the case where we don't have values from, it's possible to exit this loop probably sooner. But if the chart values can change, I mean, it's like the chart changes, right? So then that's why we are queuing something new.
Or a subchart that has default values that you only change the default values in a subchart. That's why we need all the charts, get all their defaults, extract all the values from all the charts and subcharts,
Yes.
merge them with values from, merge them with inline values, and only then we can decide is the desired state new or not.
Well, yeah, like that eliminates the possibility of doing work when you are setting values from or inline values over the chart that are just resetting the defaults, right? Like if I copy the defaults, and then it's like it's eliminating defaults causing a change. But there's a smaller subset of where you're sure a change happened, right? Like if we're only hashing the inputs external from the chart. So it's like if you want to take a secondary hash of the chart values and the chart inputs, and hash those both together as the entire config input, that totally makes sense to deduplicate work further. But like if you are looking to catch an incoming change, you don't necessarily need to read in the chart to know if a change is already coming. But it would require, I think, storing a second hash in this case because what you're pointing out is very useful. Yeah. But also if we cause a terminal error and the chart changes, right? Like the values hash is not going to be the thing that causes the re-reconcile. Like that will just be where is the event coming from? We have the Helm chart reconciler that would fire
It's the watcher.
on Helm chart.
Is the watcher on Helm chart, is the watcher on OCI repo.
Yeah. That's where we would requeue from.
And now we will have watchers on config maps and secrets.
Yes.
And they will always all behave the same.
Yes.
So I don't think we should change anything if you have watchers on config maps and secrets. We do the terminal error every time, then we wait for something to change without having to calculate any checksums. Because we now will receive events when either the chart changes through OCI events, Helm chart events, either the inline spec changes the values through events on the Helm release generation, or from values from secrets and config maps, we are now also receiving events when those changes, right?
What if
So-
the success of the Helm release upgrade depends on something that external to the cluster?
What?
I think Mateus is wondering about terminal error. And what are the cases that cause this? One is if the chart ref is invalid. The next here is, what was this? Hatch the object author. This one
No,
is,
this is the defer. Yeah.
yeah. And here, this is access denied, but this is an internal ACL spunk, and the only case here is that will change this is controller configurations. I think that's why this is done.
Mhm.
So that's like a controller restart will be needed for this to be allowed. And then this is the one that feels buggy. I think out of all of the cases, this is the one that is the spookiest because stuff can change in the case.
Yeah, it's like
Yeah.
the inputs of the ham release are not the only thing that can cause it to fail or not. There are external factors that could make it fail that
Yeah.
would
Oh, well,
not.
that's what retries are for, right? But it's like once we've
Exactly.
exhausted the retries, it's like now you're by policy saying I want to stop. But not considering something from that are inputs to the release that is not present in the object spec here feels like, yeah, I mean, this is a huge behavior change. And I can see why this would affect any number of people. And I feel like here in this case, it would be better to just like have an exponential back off. And it would be nice if as well we had a way of doing this so that we don't even have to load in the chart. Like it only happened just based off of reading config maps and secrets. Because then like you're doing only read operations to Kube API. But I mean, if you want to slurp in a chart from a source controller, then that's fine. But I think it's better in this scenario to have something that is going to check that the config changes much like you would for a crash loop backoff on a pod. Like crash loop backoff is like the mental model that I have here. It's like if
Yeah, Helm is not like that. Like how we design the Helm controller is not like that. It does not do things in a loop. That's the whole
I
idea of
mean,
retries. It
I
stops.
I can probably find the conversation that Hida and I had when we first put values from into the Helm release. And back then, it was a very intentional decision that we would not get a reactive update from the config map, but that the interval would always cause an input change. So this was incredibly surprising to me that this behavior was changed because I think it's a really big violation of the programming model.
But
And
how is wait a second? How is values from different from a chart ref? Like
how is values from different from a chart ref? I'm trying to understand your question, like the context of it.
why would we requeue if it has values from? Like chart, the values inside the chart are also inputs. And we return a terminal error and we wait for someone to change the chart. We never requeue. It's the same stuff we are now doing with config maps and secrets. We never requeue, we wait for someone to change the inputs.
I mean, we're going to be benchmarking, I guess, what it looks like for people to watch every non-related Helm secret in the cluster and to see if that's a valid way to deal with this. But from a security perspective, the default to me should be to require a label. So, I mean, it's like moving like the guarantee of this to making sure that someone has labels on their things, which is not, it's not an API guarantee, but I guess we can just plaster that everywhere in the docs, and if people run into this, then they run into it, and then now they have to label their stuff. I'm concerned about all of the users out there who have yet to update, or they've updated to this and they have this behavioral change, and their SRE teams have just never run across the fact that the thing is paused sometimes, and this is why people are getting spooky behavior, and it just erodes trust because this always worked before and now it doesn't.
I mean, we have this for 1 year now and no one complained.
That's not exactly true that no one's complained.
Yeah, but the problem is if we change it again, it's bad. Maybe people rely on this behavior.
There's
Like
a
it doesn't matter if we change the configurable or not, we have to do a Flux reconcile.
You
I
said
don't know.
even if anyone has complained, no one has complained successfully to this point.
No one has opened an issue. Like there is no issue about this.
No, there is an issue. We closed it as not planned. There's an issue that opened up pretty much immediately after we did the release that says, hey, it looks like config maps and secrets don't get reconciled anymore on the Helm release. And then there's like a 3-comment discussion, and then we closed it.
What's the number of the issue?
Let me find it. But it wasn't hard to find.
Which repo?
That was my
Controller problem.
yeah. I think all I searched was values from, and then it came up. Probably this one. Yeah.
1031.
Yeah. July 22nd, last year.
10.
Starting from 223. This doesn't happen. And then, yeah, Kingdon triaged it.
10. How? 10 what? 1023.
1031.
Three.
Helm controller. But yeah, I would expect a lot of people to be affected by this, and a lot of people to not notice that this is happening in their environment, because probably for the most part you can jiggle some things when you're like, oh, that's weird, like what's happening, and then like you change something in the chart, or an inline value or whatever, and then now it works, and you're like, I guess it's fine. But it's like, if the controller can restart and the behavior changes, I feel like this is a case where we should at least be doing like an exponential backoff. Like, I don't think that we need to, like in this scenario, necessarily follow the interval strictly, because we've reached a terminal error, right? But like before, like if it failed to release, right, like everything would still requeue on the interval, and then if your values changed, like after you noticed, the next day or something, all you have to do is change the config map and everything is fine, right? And now that doesn't work. And there's a very even just requeuing in this scenario, it's like now we have the optimization where it's like, if there's no values from, right? If the length of that list is 0, then we can get to a happy place where there's a terminal error. But if there's anything that's being loaded from values from, it's pretty safe.
What about the chart? I mean, it for me is way more important the chart than values from. The chart can change, right?
If the chart changes, then I think we're relying on the watcher. But that's concerning, 'too. 'Cause, 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 'cause
I don't know. Let's release the watchers for config maps first, then see what if people can enable them, if they don't want to enable them, if they don't want to enable any watchers, then we can reconsider this. And we need to rewrite everything. Like terminal error cannot happen in this controller anymore. And there is a lot of logic of what happens when a terminal error is returned. We can't have the stall condition anymore. So we need to rewrite a bunch of logic of this controller to change this line here.
I don't see it as that big of a change. Like,
Yeah, like terminal error sometimes makes sense, right? We recently introduced a few
No, for
configuration.
this here, because here terminal error means stall condition.
Mhm.
That means customized controller will exit fast and tell you this Helm release is in a fail state. If you don't return a terminal error, then it's never stalled, is continuously retrying. It will block customized controller into waiting for the timeout. Like changing this here, just
This-
because you have values from,
you
can
mean
have major side effects in any other places that are waiting for a Helm release. Because a case status wait, if it's not stalled, it will wait until the timeout is over. Right? Let's take Silva or some other project which have at cluster bootstrap they deploy 20 Helm releases. Each takes around 1-2 hours to deploy. If it gets to a terminal error due to retries, and I said retries everywhere, then the customization that has 2-hour timeout, it does not wait for 2 hours to give up and report the error. It exits it immediately because here is a terminal error which results in a stall condition, which tells the health check this will never reach. There is no chance this will ever succeed, right? And you basically know, okay, the cluster bootstrap is failed. I need to go and fix it. If we change this logic here and we don't return a terminal error just because they have some values from in there, then we are going to break many assumptions that people are currently have around timeouts and how long things can take, right? So there are more
because the
more
stall
nuanced
is
side
based
of it.
off of
Yes,
the observed generation,
exactly.
and the observed generation of the Helm release does not.
If you search for terminal error, you'll see that we set the observed generation only when it's a terminal error and the stalled. Search again, terminal error, do the search, and there is in the finalizer,
It's
not
this one,
here.
I think. Yeah.
Yes,
Yeah.
right. So there are many things hooked up to this logic, which have other implications around other controllers and how people are bootstrapping clusters and so on. I mean, we need to figure out, we need to pay attention that we are dealing with a GA release of Helm controller, which with this particular behavior. And we are going to change a behavior with no future flag, no nothing out of people's clusters. So that's why I'm very, very concerned about touching anything here, adding new things like the watchers, which are opt-in and solves this by relying on the watcher in the same way we rely on the watcher for when a chart changes. I feel it's safe for our users because they decide if they want to opt in into this or not. If they want to change all this behavior, right?
So what is the consequence of returning stalled versus failed in this case?
So when you return failed, the stall condition is never added. We keep reconciling in place with a message that we are going to retry, and you shouldn't give up waiting because things are being retried. That's why you are putting in your Helm release retries 1, 2, 3, whatever, to signal everybody else that don't give up on me, I'm still trying. When you return a terminal error, when you hit the retry limits,
Mm,
then you remove reconciling as the condition, you put stalled in there, then you tell everybody else, hey, don't wait for me anymore. This is a final error. We can't move the system further from this point, right? And this is something that people use with customizations, and they time their waits and interval and retries in a way that, you know, you can do these very long bootstrap procedures, very long upgrade procedures, and so on.
that
So
would
changing the behavior here can have very grave consequences that we don't understand.
Well, but would we, when we say a config map change comes in, right? Like we would need to produce a new generation of the Helm release, right?
No. So if you go, so when a new config map comes in, it's the same stuff as a new chart comes in. It's the same exact thing. We recalculate everything, then we remove the stall condition. So if you go
Yeah, so
into,
it's really not different, right? Like if a Helm, like what we're really asking for is not
The generation only changes if the spec changes. If there's a new version of the chart, only the revision of the chart changes. We react to that, but the generation of the M release is not increased.
oh yeah, it's not. It's about the stall condition or not. It's like, if there's a terminal error, we set the stall condition.
uh-huh.
If it's not a terminal error, we keep reconciling on. So K status will hang around. All the health checks will not give up on the hand release,
Mhm.
and wait until either their timeout hits 2 hours or whatever, or the retries hit the maximum, and then we set stalled. Now, the moment we receive an event, let's say the chart change, and in the future the config map changes,
Mhm.
which is not a generation change because
Uh-huh.
it doesn't change the hand release.
Uh-huh.
We calculate, we pull the chart, we take the values, we calculate, we figure out, oh, it's a drift. Reset the retries, remove the stall condition, and
Yes.
put in place the reconcile condition,
Yes.
which means now customized controller say, oh, okay, now this one has
A
been
new
kicked off,
revision.
I'm going to wait on it, right?
Yes. Uh-huh. So
And then it can actually reach a stall condition again.
I think there was a jump that happened here that that's assumed, um, which is we don't need to we don't need to change returning stalled here. Like we can keep we can return the same status stalled. Like stalled is not a guarantee that the reconcile will never func will never run.
Yeah.
There's no guarantee of that ever, right? Like if the controller restarts the thing is stalled, if a Helm chart changes, if a config map changes and the thing is stalled, the reconcile func it it's gonna run at some point, right? If you upgrade Flux, the reconcile func will run. So like we don't have to be afraid of returning stalled, but then also requeuing. Because like all
Yeah,
we're
what I
requeuing
mean
for is
is,
just like
sure, what I mean is, if we change terminal error here, we need to refactor and figure out how we can set stalled. If it's not terminal error, we need to come up with our own type error to check it, modify the way we deal with
well
functions. I mean,
that's
it's not a
happening.
change here, right?
That's happening already. So it's like right here. No. Oh, okay, I see what you're saying. Right. So it's like we're returning a terminal error. But where this is actually setting the status condition,
It's a summarize function.
it was here. Max retries right here. This is where it's marked as stalled, Stefan. That's separate from the terminal error. on the reconciler. So this code will still be called.
Can you check the summarize function? There
Some
is a, yeah.
Sure. But like you're seeing how this would not change, right? Like we're returning
Mm.
the max retries, right? The status API is already being set like internally inside of reconcile. And then like this is from within like our internal stuff, right? Internal reconcile. But then now we look for this max retries in the reconcile release func. Right. And then we're like, oh, okay, like I see this error, right? I'm patching the status object, like I'm making my promise in the API. Now it's time to make a decision about what to do with the reconcile loop. Right. So like this is very decoupled from this error state and from the status.
Wait, let's see what's happening with the drift. Because there is another thing that runs in parallel, is the drift detection.
Mm-hmm. That's for you were wanted to look at what summarize?
Yeah, summarize
Diff
deep
set.
set,
And then what part of this
summarize. No, where is
are you
where?
looking?
Wait a second.
Yeah.
Internal reconcile. Because we have another reconciler basically that does the drift detection, that action for state. But I don't know how this is affected by the config maps. Need to reread all this code. Because we have basically a parallel reconciler
Mm-hmm.
that does the drift detection. And that one can also kick an upgrade. So there is another source of how you reboot you get from the terminal state back into reconciling. If a drift detection is,
Interesting.
and I think that
But the drift detection would only be occurring for a succeeded release, right? It wouldn't be operating, we would not be detecting drift for a failed release.
are you sure? Because a failed release can result in a successful rollback. And we should
Yeah,
run drift detection for
if
the
it's enabled.
successful rollback. But that's a very good question.
That's
Okay,
I hadn't considered this at all.
I need to take a break. There is another call in 15 minutes.
Yeah, let's take a break. I really the purpose of this was just I wanted to get a feel for if this is something that we should look at doing. I can write this up. I can get the opinions of Hida, you know.
Sure.
Right? Like so I'm happy to
What
check
you
further.
what you want to do is return this error must requeue instead of terminal error.
In the
Yeah.
case where there's values from that's non-zero. I think this is
Yeah.
fine when there's no values that could change. But just in the case that there's a config map and secret that are referenced here, I think it makes sense for us to do some sort of requeue behavior. And then the question of what kind of requeue behavior here is also valid. But yeah.
But
It's-
for if you want to do this only when there are values from, uh, the watch should solve it, right? Should solve it seamless.
Yeah, of course. The
I
watch
think the
solves it.
watch is a great performance optimization, but I'm thinking about the promise that the API makes to the person, and also about like edge cases and resiliency, like just building a controller here that keeps its promises. Like I
I
think,
mean,
yeah,
I I I agree with you with like this terminal state annoys me, but I don't think we should change this only when there are values from. Like values from is solved by the watchers.
Yeah, that's like, why not change? Why return a terminal error if there are not values from, but there are charts? Like, I mean, why? The chart has values inside, so why wouldn't you return it? Like,
we're
how can you? I mean, for charts, we rely on watchers, right? And you are saying we shouldn't depend on watchers, which kind of changes everything Flux does. If we now today we decide watchers are unreliable and we shouldn't rely on them, like we need to change everything in Flux because we have
isn't it
so
gonna be
many things that relies on watchers.
isn't it gonna be an opt-in thing?
What do you mean?
The config map secret watch.
The config my secret watch will go as it is for the label that we decide.
But
So the
it'll always,
opt-in is
we're
the
thinking maybe it'll be always on by default then.
it's always on by default with the
with the
with the
labels.
label
With the
with the
default label.
label
Yeah.
with our label.
Yeah.
Now you can change it to just not Helm chart, then you
Helm
don't need to
story.
label anything, but it's enabled by default. Once you label a config map or a secret, it will automatically work. You don't need to do anything else after you upgrade to Flux 2.7.
Yes. I think
So it's
like it's
opt-in by
this,
labeling.
the behavioral promise is just slightly different, you know, between like requiring somebody to either label the stuff that wants to be watched, you know, for, and then also for, or to ask the platform admin to, you know, enable a watch on things that are more than just what Flux should be watching, like versus getting the behavior here where Flux only ever looks at what it's told to look at, and just in the Helm release spec, and you're promised that at some point this is going to converge, right? Like if I have a 2 hour,
I mean, wait a second. We are never going to do this kind of change that you are proposing by default. It will be under a feature flag because we released this in the GA version. This is the expected behavior. If we now change it, it needs to be under a feature flag.
but Stefan, I think that I'm not asking actually to change any expected behavior, right? Like it's completely expected that if this reconcile loop runs for some reason when this API is in this state, that the config map or secret change will be picked up. Like all you need to do is upgrade Flux, and then this will converge. But what's really flaky and the bad API promise here is that it's possible for that to happen flaky, but then Flux will never do it for you based off of the promise of what's declared.
Okay, put this in writing and we'll discuss
Yeah.
it. I'm done
But yeah,
for today.
let's definitely take a break. It seems like this is something that can be looked at, and we'll figure something out. I'm not saying that we have to do this, right? But from a technical standpoint, these are the things that would be considered. So
Okay.
yeah. Cool.
Cool.
Thank you, everyone.
Bye.
Bye.